Okay, had to brush my teeth, get some laundry going. Now I'm back. Quick little hour before bed because I didn't manage my time properly. Oh, because I did shit earlier. Unreal. I didn't even do anything. Played guitar for a second. I don't even remember what I did. Okay, dope. This is done. Function templates in multiple files. What does that look like? I don't know right now. So, well, we don't need anything right now. Well, that's only default parameters. I was going to say default parameters needed in the definition. Excuse me. Or the declaration. So if you have it in one file, you put it in the declaration at the top, not the definition down below. And it needs to be in the declaration so that the compiler can see that it has a default value. Otherwise, it'll be expecting a parameter or an argument. But it's missing because you want the default value. In this case, I don't know what it'll look like. We'll just say math, sure. Or, well, yeah. A little header guard action. Maybe a name conflict with some existing math and standard library, but I haven't included anything, so it should be okay. We'll just do some, yeah, regular type name shit. And I guess you could do a non-type as well. But then I don't know what that would look like. So if we did type name T and X, and then it's expecting, yeah, it's expecting a function to come after. And it's actually cool with that. But then when I call it, I guess this is what it would look like. Interesting. Okay, we'll just do type name T for now. I don't see the value of the non-type parameters right now. Oh, and we'll just say it gets a TX. Cool. Pass it 3, it returns 3. Easy peasy. Oh, well, this is indeed some definition shit going on. Cool. Seems like it's a for declaration. So far, so good, I think. Oh, it's only returning. It's not returning a value. Maybe. No, because that wouldn't have mattered. In this case, it's including this shit at the top. It's including this. And we're saying in math, do thing. And we're giving it 3. So it should use type deduction to see that 3 is an int. Yeah, which it is. I'm not sure why this is unresolved right now. Int. Maybe, do templates have internal linkage? I don't think they would, but maybe they do. So what if we just replaced it with the definition? And then we just delete math. Yeah, I mean, that works. We're not outputting anything, but it works. Oh, okay. So maybe, does it have internal linkage? I'm not sure. Yeah, it seems like it's already, yep, here we go, linker error. Nice, figured it out already. Alright, we got some template shit action. This is for declaration, so we would think, oh, hey, this is somewhere else in add.cpp. Or we have the same shit, and we're doing that. Okay, dope, we pass it this, it returns 2. Oh, or it returns 3.3. Okay, cool, because this is a double, that's an int, alright. Okay. Oh yeah, let's test that too. So if we did just a for declaration in the same file, now what would that even look like? I don't know. Type name t, void do thing, and we'll just say it gets a tx. And then we just say down here, template type name t, void do thing, t, tx, this, do thing. Oh. Yeah, it's not cool with do thing. I guess for declarations aren't possible, maybe? So maybe we have to have the definition up top? And maybe we have to make it inline too, but if it's already not exposed, it seems like we don't even need to make it inline. Or making it inline might link them up. Like a const expression variable that's inline would be local to that one file, and if we use the same one in a bunch, like let's say const expression gravity, we make const expression gravity an inline const expression gravity. That way the linker can link all of those definitions up. It seems like it's const expression. Let's just test. Uh-oh. Oh wait, hold on. Okay, seems like it can maybe be inline to do that. Yeah. The question is, why can't the compiler? Well, if it can't see the definition, it can't do it. It sees the for declaration. Oh, hold on. Ah. So it can't even call, because the definition is what instantiates the other functions overloads, I guess, or the specializations. So if those are defined elsewhere, it's not going to go and look elsewhere for them, seems like. Yeah, it'll see the definition. Or hold on, here we go. Oh, so templates only instantiate template functions. So the primary template will only instantiate template functions if the primary template is called in that file. I can't call a primary template from another file. Like, I don't know. I can only hear people yelling inside my own house, not outside. It makes sense that I hear someone outside. They're outside. But they can't fucking hear me, or I can't hear them. Let's say they're outside, they're in main, and I'm in this add.h or add.cpp file, and they're yelling in, yeah, I know, you know I'm in here. It says, let's say I'm in the bathroom. You're trying to get my attention. You see that the bathroom has the little red thing on it and it says occupied, whatever. And you know that it's me. You saw me go in here. You put my ass in here. You pushed me in and shut the door. Okay. Well, once you shut the door, this is a hyperbaric chamber, buddy. I can't hear shit on the outside. It's over. I can't help you. So sure, you see me. You say, hey, Ethan is in here. And you got my name on the outside of the door in your little main file. Yeah, but I can't help you. I can't actually give you the information you need. I can't do what you want. You got to be in here for me to do what you want. Something like that. Without reasoning by analogy, yeah, templates only instantiate their specialization template functions if the primary template is called in the file it is defined within. Excuse me. Okay. Why is it fragile? I don't know. I mean, any of the calls at compile time should instantiate the shit. I don't know. It wouldn't later be changed because the instantiation happens at compile time. And once we compile, we can't change shit. Meaning that when we compile, it will just put them there if they're not there. But assuming that we can't, and then... Basically, it seems like it's a pain to put templates in another file. Well, yeah, we put it in a header file with a header guard and we include that bitch. That way it's the definition. That way we're calling the primary template's definition. Therefore, it will instantiate its function templates. One definition rule. We're talking about some inline shit here, maybe? Alright, here we go. If we're thinking one definition rule, it doesn't see calls to it elsewhere. Or maybe it does, but it only cares about ones within the same function. Seems like one of those is the case. Oh yeah, it did say, oh fuck, these are, oh my god, I forgot, we haven't revisited in a while. Types, templates, Oh yeah, so it was non-inline functions and variables, and types and templates, or and types, templates, and inline shit. So if it's inline, it's cool, and types and templates are also cool. So we have to define the type in each file. We have to define the templates in each file. We have to also define inline functions in each file because it requires definition. Okay. Functions implicitly instantiated from templates are implicitly inline. So the linker is already going to say, hey, yo, this guy's already been instantiated here. It's just that it actually has to be instantiated, which means it has to be called from the file that calls it. Or it has to be defined in the file that calls it. Yep. Hmm. And the templates can only be called by the file they're in, kind of like a preprocessor macro, a little like variable like thing, an object like thing, can only be called within its file. We have max, which we include in foo and main, and then we can call foo from main, which likely will call max, cool, and it will output the max of stuff. So we call foo to get the max of some numbers. So we call, so we could call max directly because we're including max here. Oh, and we have a for declaration to foo instead of having to do a header file for foo. We can call foo that just outputs 3, but we can also call max 2. But foo also does max, so max is called both times. We can do it directly or through foo. Excuse me. Yep. Oh shit, here we go. Alright. You got function overloading. Yeah, makes sense. There's specific rules that allow us to resolve overload argument or overload calls. Makes sense. Yep, on the same step. Cool. Yep, default arguments are default values for a parameter that we can omit if it's on the right side. Can't do it on the left because I can't omit it and then call something else. I have to explicitly say any of the explicit parameters as an argument. Oh, okay. So we can use the template parameter declaration to declare non-template or non-type template parameters too. Instantiation, yeah. Oh, if it's due to a function call, it's implicit versus explicit if we do it ourselves. Function instance, okay. So you use the function template to create a template function? Okay. Yeah, I guess so. We're calling the template. We're not calling a function. Interesting. Well, yeah, it checks specifically and then generates based on the arguments. Oh yeah, in a regular non-template function, we can use the auto keyword, and it seems like it'll actually just generate it. Yeah. Into a function template, and then it will create an implicit instance, or it will implicitly instantiate the function template or template functions. An abbreviated function template, okay. And then this is the way we can get const expressions. Yep, past this parameters. Okay. Okay. This feels like some ambiguous shit. Let's see. We have a short 2-byte int s. Oh. At first it should probably be okay. And then it should probably be int 5 and int whatever s minus a is plus 97. I think 97 is lowercase a. My thinking is, so we have an integer and a character. That's s, right? Yeah. An integer and a character. Both of, or sorry, we have a short and a character. Both of which are subject to integral promotion, or numeric promotion to an integer. They shouldn't be numerically converted to a double. So it should be int 5 int whatever s is. Well, if we're outputting, yeah, it's converted, so yeah. Yeah, hold on. Is it int 5? And then print s. Oh wait, we only called it one time. Bro, what am I fucking doing? Hold on. Dude, I'm tripping. I got the first part, but then I thought we were, I don't know what the hell I thought. I thought that we were doing two different calls, one with 5 and then one with a character s. Bro, I'm tripping. Short s, I hate these names. Short s is so it's a 2-byte integer, okay. And then we're calling print with a 2-byte integer. Well, a 2-byte int is going to get promoted to an int, not numerically converted to a double. So it's going to be int 5. Yes. Yes. Cool. Hold on. Let me be right back. Okay, laundry is still washing. All right. Why won't this compile? 5.0f, I'm guessing there's some ambiguous shit going on, and then we're also printing with nothing. So if we're calling with no argument, oh, well that's the ambiguous part probably. So if we're doing 5.0f, it's going to get promoted to a double, so that's cool. So it should do double 5.0 or 5 because we're doing standard character output, which kills trailing 0. But the second print is the problem here, where we're calling print with no arguments, which you'd think, oh, okay, it's going to do print, the first one. But we have a default argument for the second print. And if we took off the first print and we called print with no arguments, it would do the second, well, in this case, the second print, what would be the first print, the only one with default arguments. So in this case, it's ambiguous because it doesn't know, hey, are we calling with no arguments or are we calling with a default argument? Yes. In this case, we're doing 5, and it doesn't know if the integer should be numerically converted to a long or to a double. Yep. Write a function template that allows you to do this. Okay. Let's do okay. A template named add, so we use 2 values of the same type. Cool. Okay. Sounds like we would want template type name t, type name t, and then return a t add tx ty, return x plus y, right? Then we call add what, 2 and 3? Yeah, 2 and 3, and then, or, oh, well, I guess we also want to output it, huh? Standard character output, add 2 and 3, and then standard character output, oops, add, what is it, 1.2 and 3.4? Sure. Five and 4.6 sounds good to me. Easy enough. Anything we want to check for? Nah. Because if we did it with 2 different types, like if I just did 2 point and turned that into a double, well, nothing matches because these must be the same type. Okie doke. Easy enough. I'll do this next one and then I'm going to go and get laundry. Multiply one value of this, or hold on. One value of any type and an integer, not a template type. Return the same type of that. Oh, okay. All right. And we're outputting some shit. Okay. All right, and we'll do a template type name, sure. And then we're doing returning a t, multiply, and it's a tx, and an int y. Return x times y. Cool. And it will convert these guys here. One thing to be aware of is if we do, oh, actually it's fine because we're multiplying by an int anyway. So even if we do a floating point, the common type between integers and floating points are floating points. The memory depends. So if we do like a long int times a floating point, then the common type would be whatever's large enough to fit them both, but it's fine. So now in this case, we can do character output, mult 2 and 3. And then same thing. Well, what is it? 1.2 and 3.4. Oh, 3. Oh, duh. That makes sense. Cool. Yeah. So we can give it an integer and an integer, and then we can give it a double and an integer, and then cool. 6 and 3.6. Nice. Seems good. This is kind of good. The fuck? Yeah, this is kind of good. Alright, let me pause this and then put my laundry in the dryer. Okie doke. Trying to see if I had any smudge on my glasses. It's kind of a good song. I kind of want it again. Okay, subtract. And you want... Oh, so we probably want an auto, huh? Think so. Because if we're subtracting 2 from 3.5, the common type... Well, actually, the common type... Well, yeah, we would need it to be auto. We don't want to return just the first parameter, because if we return the first parameter's type, this is fine. But if we do the first, well, and we get 4 minus 1.5 to get 2.5, and we return 2.5, a double, as an int, we get an issue. So we probably want auto, I had to say. What the fuck happened? Ah, whatever. Excuse me. Yeah, and we want type deduction here because we don't know which of these we want to return. Because otherwise we can never subtract a float from an integer if we return the integer. Yeah, makes sense. Oh yeah, true. And we could also do an auto y and an auto x. And this is a abbreviated function temp or function template. 20. Cool. Yeah, exactly. What's the output here? Alright, so we're calling this count function a couple times. So we're doing it with 1, 2 times y. Oh, okay. Makes sense that we have some static stuff. So hopefully we get 1 and then 2 probably. And then... oh, well, I guess we wouldn't even... We're not even using the value, we're just calling it. Alright, I gotta chill out with this. I'm too into it. Alright. So we have a template, type name T. We have an int returning guy, this count function that takes a T, so one one placeholder type template parameter. So type template parameter, or a template parameter, one template parameter, okay. And it's not a non-type, cool. So yeah, we're just using an unnamed variable because we're not referencing it, okie doke. So we call count with 1. It doesn't matter what we call it with, we just call it with some sort of type, okay. And it says, hey, static int c is 0, so it's created at compile time to be 0. And it's returning incremented 1, 1. Okay, so we're going to call it once for 1. We're going to call it again. We're not going to use that value. Oh, it's already been created. It's already been initialized. So we're going to do 2. And then we're going to do 2.3. And it should be 3. And then we're going to do it again. And 2.3 is a double, but it's going to use type deduction, or at least template type deduction, or argument deduction, because it's looking at the argument to say, hey, you're a double. Okay, let's create a double version. Oh, it's not going to do that. Okay, so I'm guessing, is it 1, 2, 1, 2? So it's going to do 1 and 2, because those are both calling the same instance. It's going to first create an int version, because this is an int, and then it's going to call that, and it's going to get 0 incremented to 1, so 1. We're going to call it again. Oh, especially the instance already exists. We're going to get 2. But then we do 2.3. Oh, we don't have 1 for a double. It's going to create 1 and then give us 1 and then 2. So 1, 2, 1, 2. 1, 2, 1, 2. Perfect. Yep, it'll instantiate it. It already exists. Sure. Yes, exactly. I love saying stuff out loud and then I'm reading it on the screen, but I'm actually saying it before I'm reading it. Good. 2.3, so it makes its own. Cool. Why is it calling that prototype? Prototype count double double? I mean, it's just creating its new instance. Okay, I think that's a weird way of saying that, but alright. And again, it's going to say that in this time, we're not doing type deduction, we're doing an explicit call to a specialization that exists. And it at first would have just created it, but in this case, it already exists. So it should say this here again. Yep, already exists. Cool. Oh yeah, true. And I didn't think about that part. I mean, the result's the same, but 1 can indeed be converted to a double. So we're cool. What's the output here? All right, so we're calling foo with 1, and then we're calling it with an int. We're calling it with a short, and then both of those are type deduction. So it's probably going to want to make an int version. It's going to want to make a short version, seems like, and then so those two might be unique, and then an int version already exists, and this time we're saying explicitly use that one, regardless of what type of data I'm actually passing you. In this case, it's this. And then it's going to do the int one again, except with the short value. So it'll do that one for probably the 3rd time. There's been 3 int calls and 1 short call. And then it's going to use type deduction again to call that int one the 4th time. So it looks like it calls the int one, the short one, the int one, the int one, and the int one. Okay? So the output is we have a non-template function, foo, and it takes an integer and returns the integer plus 10. Okay? And then we have a type name one that takes basically something that's not an integer, because if we call it with an integer, at least when we call it with a regular call, it'll do that. But if we call it explicitly as the template, then it will call, or it will generate an instance, even if it's also the int. And if we call, like we are here sometimes, with the non-template style of calling, it'll prioritize the non-template one, but if we do it with the template one, it'll only do the template one. So we're first just calling foo1. So we already have the integer overload, so we're going to get 11 at first. So it's going to be, I think, 11. And then we have a short 2. And we're calling. Now here's the question. Does it get promoted first before? Or does it get an exact match? Well, I think it's going to do an exact match because we don't have an explicit one that already matches. So an exact match via template might be next in line. Fuck, I think there was a hierarchy there. I think template might be next. If template is next. So if template isn't next, I think template's next. So if template's next, it's going to use type deduction because we don't have a non-template overload. So we're now at the template part. There's no non-template one, so let's do a template. Okay, we're going to create one for a short, and the short's value is 2. So we have a short that is 2. And it's simply going to return whatever that value is instead of it being plus 10. So in this case, it looks like we're going to get 2. And then we're going to call an int one. Oh, well, we're only looking at templates. We don't have an int one. We have a short, but not an int. So we're going to generate one that's an int. And then we're going to return what we have. And then we're going to do 4. And then we're going to do int s. This time we're going to take the shorts 2, but we're going to look for the int one and call it as is. So in this case, really it wouldn't matter if that was a short template call because it's the same shit. So we should probably still get 2 there because we're calling the int template. And then we have type deduction, but it's still going to favor the template. And we already have one that's an int, so then it's going to do a 6. So I'm going to say non-template prioritized, or call prioritizes non-template, so 1 plus 10. And then no exact short match, so template creates short instance, so 2. No exact template match, so template creates int instance, so 4. Yep. Calls existing template int instance with a short value 2 as int, so 2. Calls existing template instance via type deduction, or argument type deduction. Calls existing int instance, so 6. 11, 2, 4, hold on. 11, 2, 4, 2, 6. Fuck yeah, baby. This should be template. It matches it exactly. So foo int is called. It doesn't match non-template exactly, but oh wait, hold on. Oh yeah, here we go. Exactly, makes sense. It could be promoted, sure. So it's possible. but it will prefer to get an exact match, even if it has to do some template action. So, makes sense. It does foo the template short. And then here, well, we don't have it yet, so it's going to create it. Foo int isn't called because we have an explicit template call. Yep, makes sense. So it calls it. Oh, we did another one, but with a short value. So the short value is simply just converted and bop. Yep. And specifically, the type of conversion is numeric promotion. And then we call it bop. And then the last call, it's argument deduction. So we're only looking at templates. We already have an int, so we're gonna do that. Cool. Nice. Easy enough. Const expression functions. Oh shit. Okay. I gotta catch him on my sleep because I didn't go to sleep early enough yesterday. I already played my instruments and stuff today, so I'm gonna call it a little early.